Hey, it's Mr. Shrum, and welcome to the Introduction to Energy tutorial walkthrough that I am creating. And we're going to look at the lesson activity in this tutorial, and it's titled Energy Park. So, this is all about energy, potential energy, kinetic energy, and the relationship between friction and energy. And we're going to look at this skate park simulation. It has instructions here to play around with, like the introduction, the friction, and then a playground section where you can mess around and build your own track. But I'll show you introduction here. But we have a skater, and they are going up and down this ramp. And if you click the bar graph in the speed here, you can show and see the total energy in the system, how the kinetic and potential energy changes form as the skater goes up and down the ramp. And at the top, you notice that the potential energy is the highest when they are changing direction. And the kinetic energy is the highest near the bottom of the ramp when the skater is moving the fastest. The speed is the most at the very bottom of the ramp. So we can see how potential energy is tied to the position of a person in the gravitational field, and kinetic energy is dependent on how fast the person is going. Kinetic is tied to motion. Potential is tied to position. And we can also experiment with the friction part. The lower the friction, the easier it is for the skater to move up and down the ramp in a very smooth fashion. Friction comes into play when the surfaces are very rough and it exerts a force on the thing that is moving on the surface. So if we increase the friction, the person skating will eventually stop because the force acts in the opposite direction of their motion and eventually brings them to a complete stop. So when it comes to skating, you want smooth surfaces, and it's way easier to skate on smoother surfaces than it is very rough surfaces like carpet, very rough concrete. So I think that makes intuitive sense to most of us. And then we can answer some of these questions. So part A, how do the potential energy and the kinetic energy change when the skateboarder is at the top or the bottom of the hill? Why do you think this change occurs? Well, the potential energy and kinetic energy are always changing. The total energy is the same, however, its form changes. So sometimes there's more potential energy, sometimes there's more kinetic energy. And when the person's at the top of the hill, potential energy is at its highest and kinetic energy is at its lowest because the skateboarder stops for just a brief moment before getting pulled down the hill by the gravitational force. And at the bottom of the hill, kinetic energy is the highest because the skateboarder reaches maximum speed, maximum velocity. How do the levels of thermal energy and speed differ between low and high friction surfaces? How does this difference relate to a transformation of energy? So here we go. Here's a high friction. You notice that the thermal energy keeps increasing. And eventually, that's the only energy form on the bar graph. However, if we reduce the friction entirely, there is no thermal energy without any friction. So all of the energy is converted into potential and kinetic energy. But if you add a little friction, you get some thermal energy. And that's why over time, this person stops, because they have neither kinetic or potential energy. It's all used up, or rather transformed into this thermal energy, heat. We click that answer, we get another way of wording it. When friction is high, the skateboarder starts with the same amount of potential energy, but ends up moving more slowly across the surface than when friction is low. Friction transforms some of the mechanical energy into thermal energy as it scrapes along the rougher surface. The simulation shows only the changes in energy that cause the motion of the skateboarder. What energy transformations are going on within the skateboarder's body during this process? So, if you're thinking about the skateboarder themselves, there's chemical energy inside of the person, right? They have stored chemical energy, and that is being used to fuel the movement of the skater's muscles. This movement would also involve a release of thermal energy by the skateboarder. All right. So I hope you enjoyed that or learned something from this skating simulation, and see how kinetic and potential energy interplay within the system, how friction leads to thermal energy in the form of heat, and how you can have fun creating your own version of a track and see how potential energies and kinetic energies work. But that is all I have for you today. And if you have any more questions about the rest of this tutorial, let me know and I will get back to you. And you can schedule a one-on-one tutoring session or come to office hours. And I am always open. The door is always technically open since we're, virtual. But yeah, just send me a message and I will help you out as soon as possible. All right. See you guys later.